I'll give you a couple of examples and you try to understand what exactly we are going to talk about. Okay. Now, all of you have seen that, whenever you put a cotton wick in the oil is going to rise up and then you can light that particular cotton. Correct? Oil is going against the gravity, isn't it? This is one example I'm giving you. Now, try to understand what phenomenon might happen. Hmm? This is one example. Or when you see a soap film, okay, all of you would have done this. You'll take that soap water and then you put it and then you're going to blow it. You see the bubbles, correct? Soap bubbles. Why do bubbles have spherical shape? Why not some elongated, cylindrical kind of shape? Why it has to be only spherical? This is one example. Now try to think of what we are going here. Because for the first one, the first example is oil, which is a liquid. The liquid is rising up, correct? And in the second example, again, a soap film. It's a liquid layer. Liquid layer is becoming like a sphere, correct? Now, these examples why I'm giving because you are about to learn another concept called as surface tension. Alright? Now, the surface tension is an extremely important and also it's a very simple concept. Understood? Now, let's talk about that soap bubble example. See, in the soap bubble example, when you blow the air into that soap film, it forms a spherical shape, correct? It's a sphere. Now, why sphere? It has a particular reason. Like it doesn't become just sphere. Randomly, it's not a sphere. We have a reason for it. In the sense, why we need to have a sphere or why that particular soap, it forms a sphere. The reason is, for any given volume, sphere has the least surface area. Understood? For any given volume, sphere has the least surface area. So any body or anything which is having some particular volume because every body whatever you see has a volume, correct? Now liquids if you take in particular, they don't have a particular shape, but they have a particular volume, isn't it? So for a given volume, a sphere has the least surface area. Now, why we need to consider about the least surface area? The reason is whenever we have least surface area, the surface appears to be stretched. It's like a membrane and you're stretching the membrane. In the sense, take an example of rubber. Okay, you take a rubber sheet, you stretch the rubber sheet. It forms like a membrane, correct? Now, a spherical object, or you can say that any body having the volume, when it becomes a spherical structure, the surface of that spherical structure appears to be stretched. Okay? Now, this membrane has a tension, correct? This membrane, which is having a tension, we call this as surface tension. Now, surface tension, to understand this surface tension, let's talk about energy. In the sense, the free surface what you have, right, on top of a liquid or any of this, like water, oil, whatever you get. On top of it, we call it as free surface. Free surface has extra potential energy. This is why we get surface tension. Alright? This is the reason for surface tension. Now let's try to formally understand what is surface tension. Okay, now surface tension is what? It is the virtue by which there is a small membrane on top of a liquid. Okay, and that liquid has some tension in it acts like a stretched membrane, right? The tension is what we call as surface tension. Alright, this is more like a formal way of expressing what is surface tension. Mathematically, surface tension is what? Total force per unit length. So S is equal to F divided by L. Now the SI unit for this one is Newton per meter or dyne per centimeter. This is in CGS. One thing you have to understand is that surface tension is a scalar quantity. Okay, it has no direction Surface tension is everywhere on the surface of the liquid. Alright. Now this is more about basics of surface tension. In the upcoming videos, you will understand how the surface tension actually exists for a liquid.